Hello, everybody. So in this video, I'm going to be discussing the chi-square independence test in Rguroo. So let me go ahead and share my screen and we'll get started. All right, so first thing I want to talk about is the chi-square critical value table. So when we do the chi-square independence test, we're going to be using both the critical value and the p-value approaches. So the p-value approach is the same as we've been doing. The critical value approach, if the test statistic you get from Rguroo is greater than the critical value, we reject, and we can get the critical value from this table here. And I'm going to show you how to get the critical value from this table as we do our examples. Let's go to our first example. We are looking to determine whether having a college degree is dependent on gender. 200 people are sampled and they are asked their gender whether they have a college degree. Assume our significance level is 0.05, and then we have this table is our results. Now note that this test is always about whether two variables are independent or dependent. That's the core of this test. So the null and alternative. So the null is always that the two variables are independent. So gender and having a college degree are independent. And then the alternative is that they are dependent. So it's going to be not an equation here, it's going to be a sentence. And I always write it as the independent variable and then the dependent variable. Doesn't super matter, but I like to write it that way just because it sounds better. Because we know that having a college degree would depend on gender, not the other way around. So I always put the independent variable first. But like I said, if you write it the other way, I will take it. And then what is the test statistic and what is the p-value? So, and then we're going to make our conclusions. So let me go to our Rguroo and we're going to enter all this in. All right, so we have to create a table for this. So we're going to go under data, data import, create new table. And so I need to add, so I'm going to add everything that is not in the totals. So if I look back at my table here, I have 2 rows and 2 columns. We don't include the total row and total column. So I need to add 1 more column and 1 more row, and then I can name my rows here. So has college degree and does not have college degree. And then I can click on the title here and then type the names of the columns in the boxes. So this one is female, and then this one is male. And then I can enter all the numbers here in my boxes. So I am entering everything that's not a total. You cannot enter the totals here or it will be incorrect. All right, and then my row label. So what is the row variables? The variable in our rows is college degree. And the variable in our columns is gender. And then I'm just going to save this as gender and college degree. Okay. And then I'm going to go under analytics, analysis, and contingency table. I'm going to select my data set, select the 2 variables. It doesn't matter what order they're in, just select them both. And then check chi-square and then enter the significance level, which is 0.05 here. Hit the eyeball. And then this is my test statistic. Oh, wait, something's wrong. Oh, I forgot to select var name here. You have to select var underscore name there also. Hit the eyeball. All right, there we go. So I get a p-value of 0.154 and a test statistic of 2.031. And this is also the degrees of freedom. We're going to need that when we look at the table. So remember that we have 1 degree of freedom. So let's now look at the table and get the critical value. So with 1 degree of freedom and 0.05 being the significance level, the critical value is 3.841. So since the p-value of 0.154 is greater than our significance level of 0.05, that means we fail to reject the null. And then with the critical value approach, if the test statistic is greater than the critical value, you reject. So since the critical value is greater than the test statistic, that means you're failing to reject. And then our conclusion, so since we failed to reject, that means we don't have enough evidence that HA is true. So we don't have sufficient evidence that gender and having a college degree are dependent. All right, let's do another example. We're looking to determine whether age has an impact on income level. 250 people are sampled and asked their age and how much money they make. Assume alpha equals 0.1. The following are the results. All right, so we can see here we have 3 rows and 3 columns, excluding the totals. We need to remember that when we put it in our Rguroo. All right, the null and alternative. So age is my independent variable and income level will be the dependent variable. So because age impacts income level. So I'm going to write it as independent and dependent. So like in that order. So write the independent one first in my null and alternative, followed by the dependent. So age and income level are independent is the null, and the alternative is that age and income level are dependent. You can see I put age first because it was the independent variable. And then what's the test statistic and what's the p-value? And then using our critical value and p-value approaches, we're going to determine whether we're rejecting or not. So let's go to our Rguroo and enter all this in. So first of all, I'm going to exit out of everything that I did from the last question. So exit out of here, close that out, delete that old data set, right click and delete. All right, data import, create new table. So I need 3 columns and 3 rows. And then I can start naming all my columns and rows here. And I'm entering in all the numbers, excluding the total row and the total column. And I was just hitting, you can either click in the boxes, you can also tab between the boxes, however you want to enter it in. So my row label is income. That's my rows, and my column label is age. And then I'm just going to save this as age and income. And then just save the data set. All right, and then analysis, contingency table, select the data set, select the variables, select the var underscore name, check chi-square, and enter the significance level, which is 0.1. And then we're going to hit the eyeball. And then you can see I have 4 degrees of freedom here. My p-value is 0.031. My test statistic is 10.631. All right, and then let's actually, before we do this, let's find our critical value. So our significance level is 0.1. We had 4 degrees of freedom. So our critical value is 7.779. And so that's our p-value and test statistic, and the critical value. So this p-value 0.031 is less than the significance level of 0.1. So we're going to be rejecting the null. And then since the test statistic is also greater than the critical value, that also means we're rejecting. And then our conclusion. So since we reject it, that means we have enough evidence that HA is true. So we have sufficient evidence to conclude that age and income level are dependent. All right, let's do another example. We're looking to determine whether a political party has an impact on support of a new bill. 300 people are sampled and asked their political party and whether they support the new bill. Assume your alpha is 0.01. The following are the results. So we have 2 rows and 3 columns here. The non-alternative. So political party is the independent variable and the support of the bill is dependent. The political party would impact the support of the new bill, not vice versa. So my HA, I'm going to write the independent variable first when I list them. So political party in support of the bill are independent and political party in support of the bill are dependent. The null is always independent. The alternative is always dependent. So let's go to our Rguroo now and enter all this in and get our p-value and our critical value and our test statistic. So let me go ahead here and close this out and close this and delete the data set. All right, data import, create new table. So I said I need 3 columns and 2 rows. And then let me start naming all my variables here, all my columns and rows. So Democrats, Republicans, and independents. And then support bill and do not support bill. And then I'm just going to type in all the numbers that aren't totals. Oops. And then my row label. So my row variable here is going to be support of bill. And my column label, oops, is going to be political party. And then I'll just call this political party and support of bill. Okay. And then analysis contingency table. Select the data set. Select both variables. Select the var underscore name. Check chi-square and enter the significance level, which here is 0.01. And then we're going to hit the eyeball. And I get a p-value of 0 and a test statistic of 34.279. And then I have 2 degrees of freedom. So for 2 degrees of freedom and a significance level of 0.01, my critical value is 9.21. So let's go back to our example now. So since the p-value is less than the significance level, 0 is definitely less than 0.01, and our test statistics is also greater than the critical value, that means we're rejecting the null hypothesis. If we reject, that means that we have sufficient evidence that HA is true. So we have sufficient evidence to conclude that political party in support of the bill are dependent. All right, let's do one more example. We are looking to determine whether use of Instagram is dependent on the region of the United States the person lives in. 400 people are sampled and asked what region of the United States they live in and whether they use Instagram. Assume your alpha is 0.025, and then we have this table. So I have 2 rows and 4 columns here. So I'm saying, so region of the United States would impact use of Instagram, not vice versa. So I'm going to write in independent, write the independent variable first in my null and alternative. Like I said, doesn't super matter, but I like to write it at the independent variable first. So my null is that they're independent. So region of the United States lived in and Instagram used are independent. And the alternative is that they're dependent. Let's go to our Rguroo and get all their information. Okay, so let's close this out here and close this out and delete that data set. Right click and delete. All right. Now let's go under data import, create new table. So I have 4 columns and 2 rows. So let's start entering in all of my titles here. And then entering in all the numbers that aren't totals. And then my row label is use of Instagram. And the column label will be region of United States. And then save it as Instagram and region. All right. And then analysis contingency table. Select my data set. Select my 2 variables, which I realized I typed Instagram wrong in that title, but it's fine. It was just a typo. It doesn't really matter. And then chi-square, and then significance level is 0.025. Hit the eyeball, and I get a p-value of 0.995 and a test statistic of 0.074, and we have 3 degrees of freedom. So let's get our critical value first. So 3 degrees of freedom and 0.025 significance level gives me a critical value of 9.348. So my p-value 0.995 is definitely higher than 0.025. The critical value is also higher than the test statistic, so that means that we're going to be failing to reject. If we fail to reject, that means we don't have enough evidence that HA is true. So we don't have sufficient evidence to conclude that the region of the United States lived in and Instagram use are dependent. And that's it. So that is the chi-square independence test and Rguroo. If you have any questions, please feel free to reach out.